2.8, solving inequalities in one variable. All right, so basically, in this, your answers look very different than like what you would typically be like used to, I guess.
Oh, great.
Like again, it's really easy. Like it's not hard at all. It's just different. So f of x is equal to 5x plus 3 times x squared plus 6 times x minus 1. These instructions say determine the values that cause the polynomial function to be 0, positive, and negative. So we should know how to find zeros. That's something that we have been doing. So how would I do that?
So all of those equal to 0.
So 5x plus 3 equals 0, x squared plus 6 equals 0, x minus 1 equals 0. So x equals negative 3/5. X is equal to plus or minus the square root of negative 6. And x is equal to 1. Now, is the middle one going to give you a real solution, or is that a real 0? No, so we can cross it out. So now what we do, skip a line or two. I'm going to draw a line. We're going to put these zeros on it, so negative 3/5 and 1. Now, we want to know what happens in each of the ranges. So, a number that's a little bit bigger than negative 3/5 would be what? Sorry, I guess technically a little bit smaller.
1/5? Oh, wait.
Do something that's really easy, like a whole number.
3. I don't know.
What?
How about negative 1?
That would work.
All right, so take negative 1 and we're going to plug it in up here. So 5 times negative 1 is negative 5 plus 3, it's still negative. So we're going to draw a little parentheses and put a negative sign. Okay, and we're going to do that for each one of them. Okay, so now in the middle one, negative 1 squared is positive 1 plus 6, so that's still positive. And the last one, negative 1 minus 1, that's negative 2, so that's negative. So negative times positive is negative, times negative is positive. So in this region, it's going to be positive.
What?
This is easy. Is that it?
I mean, we've got to do it in each section, but yeah. So in the middle section, if 0 is an option, pick 0. So set it up. So positive, positive, negative. So what would that give us in that region? Negative. All right, and then over here I would try 2. So that gives us positive. More often than not, it's going to alternate. Okay? Positive, negative, positive. It's not always the case, but that tends to happen. Okay? Don't just assume that if you do get like the 2 positives back to back that it's wrong, because there are a few that does happen on, but they tend to alternate. So the way you should have your answer, your zeros are x is equal to negative 3/5 and x is equal to 1. It's positive from anything this direction, so negative infinity to negative 3/5. We do not include the zeros. Union with 1 to infinity. And then it's negative in that middle region, so from negative 3/5 to 1. Alright, same instructions, number 6. F of x is equal to x plus 2 cubed times 4x squared plus 1 times x minus 9 to the 4th. So to find my zeros, I set each piece equal to 0. When it's something really simple, I don't even care if you like actually show all the steps. You can literally just right here tell me that x is equal to -2.
What?
I'm finding the zeros. This middle one, not quite so easy. Okay, it's going to be x squared is equal to -1/4. So then x is equal to plus or minus the square root of -1/4. That's not going to be real because we've got a negative under the radical, so I can just get rid of it. Over here, this is just going to be x is equal to 9. So my 2 zeros are right here.
You have to draw the little thing again.
Are you always going to only have 2 zeros?
No, not necessarily. Like in this case, we could have had a third one.
Yeah, that's what I was thinking.
It just, and technically, like if you remember when we talked about multiplicity, in reality, this 0 occurs 4 times. But we only need to write it once because it's not going to change anything ultimately. So -2 and 9. And with these, when we do go to plug in a number, keep in mind that these powers are outside. Okay, so that could potentially change the result from inside based on whatever it is. So let's say -3 for the first one.
Negative.
Okay, negative,
Positive.
positive.
Negative.
You sure?
Wait, negative 3 minus 9.
Raise to the 4th. What does that do to the sign?
It would be positive.
So that's going to be positive.
I forgot that one.
So ultimately, this is a negative. How about the middle one?
Negative.
0 plus 2 is, it's positive.
Positive. I would use 0 because it'll make it easier to think about.
Positive. Positive.
So that region is positive.
Whoa, who knew?
Surprise. And the last one, I would probably use 10 just because then you're not getting something super
Positive.
obnoxious, but
Positive. Positive.
so this is one where they did back to back. Okay, but what this tells you by the fact that there's a 0 here is that 9 is not included. Okay, so when we go to write it up, our zeros are at x equals -2 and x equals 9. We're positive from -2 to 9, union with 9 to infinity. Okay, you do have to write them separate again because 9 is not included. And then it's negative from -infinity to -2.
I got to do it at the infinity sign again. Shocker. I need to spend days making those legible.
Alright, so the next ones say complete the factoring if needed and solve the polynomial inequality using a sign chart Okay, this is called a sign chart, this positive, negative thing. Okay, it's just called a sign chart. Nothing crazy. So basically now we have inequalities. So the first question that we're going to ask ourselves is what values do we need to make it true? Your inequality, if it's greater than, okay, we need positive. If it's less than, we need negatives. Okay, if it's less than or equal to, then we might need 0 as well. So we're going to look for the values that basically make the statement true. But we have to figure out what they are. So starting with 8, 2x plus 1 times x minus 2 times 3x minus 4 is less than or equal to 0. So, with it being less than or equal to, what values do I need?
Negative anything or less than 0.
Okay, I need the negative values.
Or 0.
Okay, yeah, technically 0 can work. Or we need, let me rephrase, we don't need negative, it's not negative numbers that we need, it's negative regions. Regions that make the problem end up negative.
Okay.
So like how up here, let's suppose that this one was a less than or equal to 0, okay, just the hypothetical. I don't even know if that would actually work with this problem. But the only region that we would care about is that negative infinity to negative 2, and that would have been our answer. So we're going to find all the regions, and then our answer is just going to be the ones that fit the criteria that we're looking for. So I still need to start out with zeros. So I've got x equals negative 1/2, x equals 2, x equals 4/3. So we're still going to do our sign chart. So now I've got 3 zeros going on, so make sure you put them in order. Negative 1/2, 4/3. I have to think about what goes in order. And then 2. Back to the pre-algebra number line days to get everything on here in the right order. And then I'm just going to go through and set up. Apparently this is deciding it's going to spaz today. Alright, so when you have negative 1/2, you need something to the left of that. I would say go with negative 1. Just always pick the easier numbers, okay? I'm trying to talk you through my process of how I decide what number to pick. Not that it matters. You could pick negative 500 for all I care. I just try to pick an easy number. Try to pick like
Negative.
increments of zeros or 5s or something like that to make it easy. So, if I do negative 1,
Negative.
negative,
Negative.
negative,
Negative.
negative. So that's going to come out to be
That reminds me of fun dip. Oh my gosh. Literally yesterday, this kid probably bought 20 fun dips. I was like, oh my gosh.
We can use
On
0
like
now,
separate
right?
orders. I was like,
I was going to say, do they realize they would be better off to buy their own box if that's what
no,
they're
really
doing?
though.
Positive.
Hey,
I'm
hey,
using 0.
whatever floats their boat, I guess. Exactly.
I'm
You're
using 0, and it would be positive, negative. Hold up.
Negative.
Yeah.
So
So that whole thing's
Oh.
negative.
results in positive. And honestly, if you don't want to write the actual names down here, you can just write like a giant plus or minus sign too. Like, I don't care. Just
On a completely like random note, can I switch yearbook in my study hall today? Because I told Miss Marshall I'd get help from her in 4th period.
that's fine. I don't care.
You can use 1 for this one. So.
Wait,
You
no,
can't
you
use
can't.
1. 4 over 3 is bigger than 1.
Dang it.
Oh, duh. Wow.
So this is one where it's kind of weird because you got to find a number that's bigger than that, but
So it's bigger than.
sometimes you have to use a fraction, so it's kind of like,
It has to be bigger than 1 1/3, but less than 2. So like
so you could use like 1.5.
1.5. Awesome.
We're
Positive.
Positive. Then negative.
Yep.
Positive. I mean negative.
positive.
Yeah.
Right?
I think about it. Sitting there, I was like, 3/2, 9/2. I had to like convert it to a fraction if I don't have my calculator in front of me.
Okay, 3 times. Well, it'd be
Alright, then it's all negative. So this one you can use 3.
Oh, when you said all negative, I had moved on to the next thing, and I was like, I don't think those are all negative if you put.
3.
So
Okay,
positive?
positive.
Mm-hmm.
Positive. Fun.
I'm glad something's positive in life or a problem.
All right, so we need negatives. Okay, I don't know why I just wrote
So
negatives.
only the negative region zeros work.
For this particular problem, we need negatives because it's less than or equal to. So our solution then would be negative infinity to negative 1/2. Now, because it's less than or equal to, 0 works. So I'm going to include it. Okay, if it was just less than, it would have been a parentheses instead, and I would not have included it.
Wait, can you repeat that?
So since it's less than or equal to, I need negatives and I need zeros. So it can be anywhere that it's 0/negative, so I'm including.
So it would be bracketed 4/3 and to 2 as well, both ends
Mhm.
bracketed because they are.
Union with,
include
yes, bracket 4/3 to 2.
Almost like concluded and was like, that's not it. Oh, I forgot they used. You'd think I'd get better at writing U's because of stats. Even if I forget upside down. Oh. Is that it?
I was just debating. I think we're going to do one more of this type and then one more problem that's a little bit harder, and then we'll be done.
We don't need
That's what we're
them
gonna
all
do.
that harder. I think we're good.
All right, 10, 2x minus 7 times x squared minus 4x plus 4 greater than 0. So this is one where they commented in the instructions you may need to continue factoring it. This is not factored all the way for you. Okay? So we're going to need to factor that x squared minus 4x plus 2.
X minus 2 times x minus 2?
Yep.
Or x minus 2 squared. I guess it'd be the same thing.
So we'd have 2x minus 7 times x minus 2 squared. Since we only have to worry about it the one time, we can just write it that way. Now, what values am I looking for in this
All
problem?
negatives. Wait. It has to be bigger than 0. Oh my gosh. I can't today.
So I need positives,
I'm done.
not including 0. Okay, so when I get out my answer, I'm not going to be bracketing anything because I don't need zeros. Okay, it's just all going to be parentheses. I guess I should actually find my zeros first.
I was actually doing the same thing.
Because I should write what they are.
I was like, wait, what am I supposed to write here?
So we've got x is equal to 7/2. It's kind of a fun 7. And x is equal to 2. It's the little things.
Oh, we need those.
Yesterday, one of my classes told me that my 7 was really long. Like the top of it. I was like, okay.
Nice.
Well, it's like you care.
I was like, okay. I didn't think it was anything crazy, but all right.
Wait a minute. 2 and then 7/2, right?
Yeah, 7/2 is like 3.5. So I'll write it as a fraction and a
Thanks.
decimal
I
for
was about
those
to
of
do
you
the
who
same
like
thing.
one or the other.
That way when we're
Okay, so
looking
this
for
one you could
numbers,
use
actually just use
0.
4 then, but like.
I would use 0 for
Yep.
Oh my gosh, I forgot to draw the little pieces.
Negative.
Oh wait, I'm drawing. I don't need 3. I just need 2 of them because there's only 2 factors. Just keep in mind that this second term is being squared, so just keep that in mind. So with 0, we said that was negative, and then this one, positive.
I have a never mind.
Negative. Wait, 0 minus. Oh, duh. Never mind. Just ignore me.
Okay, then
Okay.
next you can
Use
like
3. 3 times 2 is 6. Minus.
negative.
Mm-hmm. 3 minus 2 is 1. It's positive.
So that's another one where we had back-to-back negatives.
And you use
4.
4.
Positive. Positive. Well, and I are like in sync. Positive.
So it comes out positive. So our solution,
You want positives, so it's only
It's only that one.
7 over 2 and 50.
yep.
Sweet.
I think I get this. We don't need harder.
It's not really harder. It's just adding one more thing to it. But it's not like it doesn't drastically change the answer. So these are nice. They just give you the one line is greater than 0, equal to 0, whatever the situation is. Okay. On occasion, you might have one that is a fraction. Okay, where you've got like function over function, and all that does is add on some value being undefined. Basically, what value makes that function undefined? So that's where the denominator is equal to 0. Your zeros are still where the numerator is equal to 0, and so the only difference is you can't use whatever that denominator value is because it makes it undefined. So we're going to do one of those, and then we will be done with this section. I'm not going to do any more than that. So f of x
Yeah, I like breathed in and it didn't work.
is equal to 2x minus 7 times x plus 1 over x plus 5. So this asks me to find zeros. It asks me to find where it is undefined.
Oh boy.
It asks me for where it's positive and where it is negative.
I just don't understand how you went to college and were like, I want to study math.
If I hadn't decided that till I got to college, it's probably not what I would have done because college math was miserable.
Yeah.
But I haven't used any of that since.
Just like I'm never going to use chemistry yet. I'm still stuck crying about it.
Might be surprised. The other day I thought I was going to have to do a chemistry experiment because I was out of baking soda. Greatly needed it because I was making banana
bread.
bread.
Sit there and be like, okay, but how do I need to balance this equation or do an entire conversion factor?
All right, let's start with the easy thing. What are my zeros?
2x minus 7 and x plus 1 are the things you have to set equal to 0.
So you'd have negative 1 as one of your zeros and 7 over 2. Yeah. That.
So those are my zeros. Where is this undefined?
At x.
5. Negative 5.
Negative 5. Okay, so you set that. Set the bottom, the denominator. It was about to all run together. Same thing.
So
Equal to 0.
The denominator.
Yeah, I was like bottom denominator. Like what? It was about to all run together.
Now we have to do then everything.
So then now we're gonna set it up. I'm gonna go down here to do it just so that there's room, because this one, like I said, is a little different. Okay. Now, we still count where this is undefined when we put it on here, but it is not able to exist there. Okay, so we still write -5, okay, -1, and then 7/2. But what I do is I put a line through -5 because it can't exist there. So if I were to be answering questions about where it's greater than or equal to 0, let's say, and this happened to be in there, this value wouldn't be included because it makes the denominator 0. Okay, so it goes there for the purposes of finding your regions, but it does not get included because it would make the denominator 0 and thus your whole problem undefined. Okay, so now when we do these, let me get some area here to work with. Okay, I set this up the same way. So I've got 2 parentheses on top and 1 on the bottom. So it's going to look like this, okay, when I'm looking at my signs. Okay, 2 on top, 1 on the bottom. All right, so there we go. Okay, now I can see the whole thing. All right, so picking a value to go in here.
Negative. Oh, sorry. I just choose -6.
That's fine. So what happens when you do that?
Negative.
Okay, so what does that result in?
Negative.
Next one.
So -2.
So what happens with that?
Negative.
So that's going to give me out positive.
Negative.
Positive.
It's going to give me out a negative.
Here you can use 4. So positive.
So it's going to give me out a positive. So then up here in my positives, I'm -5 to -1, okay? They're parentheses because I'm not including them. It's just asking for positive, it's not asking for 0. Union with 7/2 to infinity. Negative from -infinity to -5. Union with -1 to 7/2. Okay, not too bad, right? Pretty easy. All right, so then as far as problems, you'll have tomorrow to do them, so don't feel like you have to do them now or tonight. Let's see. 3. Nine, 11, 25. That's good. 25 is just kind of the reverse of 26. Instead of there being 2 things on top and 1 on the bottom, there's 2 on the bottom, 1 on the top. So
She says it's not gonna work.
no, you can do it tomorrow in class.